Welcome to Next Gen Manufacturing. You know, in the world of high-tech production, we're always obsessing over the latest software, the smartest robots, the cutting-edge materials. But what if the real key to unlocking more speed, more power, and more precision was hiding in plain sight this whole time? Well, today we are talking about the component that is the true heart of the machine.
So let me ask you this. When you picture a high-tech CNC machine, just carving out a super complex part, what do you think is the most important part of that whole operation? Is it the cutting tool, sharpened to a perfect edge? Or maybe it's the really sophisticated software running thousands and thousands of lines of code? Well, what if I told you it's actually something else entirely?
Yep, it's the spindle, that rotating core of the machine that literally translates all those digital commands into physical reality. Honestly, understanding this one single component is the key to unlocking massive gains in efficiency. And today, we're finally putting it in the spotlight where it belongs. Okay, so let's start with the basics. What is a spindle, really? Because I'll tell you right now, it is so much more than just a motor. It's actually this complex assembly that has this huge, outsized impact on the entire machining process. The best way to think of the spindle is like the wrist and hand of the CNC machine. Right? It's a whole assembly. You've got a motor that provides the power, a shaft that acts kind of like the arm, and a taper that grips the cutting tool. This is it. This is the final critical link between the machine's digital brain and the actual physical work getting done. But here's the thing. A spindle's job isn't that simple. It's got right in the middle of this constant balancing act that every single machinist faces. It's this fundamental trade-off between raw, brute power and incredible blazing speed, and it's the spindle's design that decides where that balance falls.
And you can see the challenge right here. I mean, for heavy-duty roughing, you need big tools taking these deep cuts. That requires immense rotational force, we call that torque, at slower speeds. But then, for that delicate finishing work, you need tiny little tools spinning incredibly fast to get that perfect, clean surface. It's the classic dilemma, right? You just can't have maximum torque and maximum speed at the very same time. You got to choose.
So this brings us to another really critical piece of the puzzle, the physical connection. We know the spindle holds the tool, but how it holds on is just as important for stability, for accuracy, for everything. Let's take a look at the two main systems people use.
So, the two big players in the game are CAT/BT and HSK Holders. CAT holders, they're the workhorses, especially here in the US. They use something called a V-flange and a pull stud to lock in tight. They're super robust, great for general purpose work. HSK, on the other hand, that's a German design with a hollow shank. Now the magic here is that it engages both the taper and the face of the spindle, which gives it this fantastic rigidity and repeatability at high speeds. That's exactly why you see it all the time in high-efficiency aerospace and medical machining, where precision is absolutely everything.
Now, if we really want to master the spindle, we have to learn to speak its language. And the two most important words in that language? Torque and horsepower. Now, they might sound similar, but believe me, they describe two very, very different kinds of power.
Okay, here is the absolute best way to think about it. Torque is a tractor. It can't go very fast, but there is a ton of power behind it. Horsepower is a race car. It can go incredibly fast, but it can't really pull or push a heavy load. Let's break down exactly what that means for a machine tool.
So torque is that raw rotational grunt power. It's the tractor's ability to just push through resistance no matter what. In machining, that means powering a big tool through a tough material like titanium without the spindle even thinking about stalling. It is pure, unstoppable force. Horsepower, though, is all about the rate at which work gets done. It's the race car's top speed. This is absolutely crucial when you're using those smaller tools in softer materials, like aluminum. You need that high RPM capability to get a clean surface finish and just remove material as fast as possible.
So how in the world does a machinist find that perfect sweet spot for any given job? Well, they don't guess. They consult the spindle's playbook, the torque horsepower chart. This one single graph tells them exactly what RPM to run for maximum torque when they're doing heavy roughing, and then where to find that peak horsepower for high-speed finishing. It's an essential guide to getting the most out of the machine.
So all of this, the tooling, the trade-offs between torque and horsepower, it all builds to one single critical decision: choosing the right size spindle in the first place. This is where everything we've talked about really comes together.
In the US, the two most common sizes you're going to see are Cat 40 and Cat 50.
The CAT 40, that's your versatile all-rounder. It's perfect for the vast majority of jobs that use tools half an inch or smaller. But if you need to use a big 1-inch end mill, especially in a super tough material like Inconel or titanium, you absolutely have to have the larger, more robust CAT 50 to handle those immense forces.
And you know what? It all boils down to a pretty simple principle of physics. The bigger the number, so CAT 40 versus CAT 50, the larger the taper of the tool holder is. And that larger taper creates more surface contact inside the spindle, which directly translates to a greater ability to deliver torque. It really is that simple.
So at the end of the day, getting the spindle right is, well, it's everything. The right spindle is what unlocks the full potential of your expensive tooling. It's what prevents broken tools, scrapped parts, and all those costly production headaches. It is the absolute foundation of efficient, precise, and profitable machining. Period.
So while the right spindle is busy making the parts we all need today, the perfect spindle, the one that perfectly balances power and speed and precision for a very specific job, that's what's going to unlock the manufacturing innovations of tomorrow. It kind of makes you wonder, right? What new capabilities are just waiting to be unlocked, and what will you build with them?